Okay, thanks, Carly, and afternoon to everyone. This talk is in two very distinct halves, and in the first half, I'm gonna interest you. I'm going to try to interest you in the heretical notion that gardens are indeed already long-term experiments. And in fact, this is not a new idea. In fact, when I wrote my very first gardening book about 20 years ago, I said exactly that, oddly enough, in the introduction. And I still think it's true. A garden is an unplanned, slightly out of control, usually unmonitored scientific experiment. And that's the problem. They're really not monitored. They're years and years of work and manipulation towards a particular end. Trouble is that end keeps changing, especially if the ownership changes. But it just every now and then, a garden really is monitored. And then we begin to see what you could actually get out of gardens if you actually treated them as scientific experiments. So this is what I said 20 years ago, and I still think it's true. Gardens are long-term experiments. Trouble is, they're mostly long-term experiments in which we've no idea what the hell's going on. But just now and then we have. And so this is why I wanted to mention my hero here, Jennifer Owen, in the center of this picture. Here she is getting her Veitch Medal from the Royal Horticultural Society, from the President, Elizabeth Banks at the time on the left, and the Director General, Sue Biggs, on the right. And Jennifer Owen monitored the wildlife in her garden, her own private garden in Leicester, for 30 years. And she reported the results in these two wonderful, groundbreaking books about the first 15 years and then the complete 30-year story. And one of the things she did throughout the whole of that time was she ran a malaise trap. In fact, this is it. This is a picture of the scanned slide of the actual malaise trap that she ran for 30 years. She did lots of other things too, but this is just one of them. And if we look at what she found from that malaise trap, I mean, bearing in mind here that, you know, a malaise trap isn't exactly what you would use to catch moths, for example, but nevertheless, leaving that aside, this is a 30-year record in her garden of total numbers of butterflies, hoverflies, large moths, solitary bees. She didn't sort solitary bees for the first 3 years, so that starts 3 years in. And the thing about these numbers is they're just wonderful, aren't they? I mean, there's all that up and down that you expect with wildlife, invertebrate populations anywhere. But they're all vaguely going slightly, to my eye anyway, in the wrong direction. And I would dearly love to know what happened in the last 20 years. I mean, I really would. It's just terrible that it all stops in 2001 for various reasons. So that's your first lesson about long-term experiments, basically, which is that however long they are, it's never long enough. You'd always like to know slightly more, wouldn't you? Now, the thing about gardens as long-term experiments is that despite this wonderful record from Jennifer Owen's garden, actual real private gardens don't make terribly good long-term experiments. And one reason they don't make very good long-term experiments is that every garden is different. So they're essentially unreplicated and unreplicatable, really. And there are all kinds of issues with ownership and tenure and so on. But gardens don't need to be existing private gardens. You can have experimental gardens quite easily. And I think what that might look like is shown by the recent RHS experiment, the Plants for Bugs project, which some of you may may already know about. This is absolutely brilliant experiment, which I had a small hand in, and it's an attempt basically to figure out what the importance for wildlife in gardens is of plant provenance. Does it matter if plants are native or not for the wildlife in the garden? And to do that, they set up lots and lots of little experimental gardens. I mean, they're just plots, small plots, as you can see, but basically everyone is like a small garden or a small part of a larger garden, and shows all the characteristics, I think, of a nice long-term experiment. Hard work at the beginning, setting up, obviously. Harder work actually extracting information from them, collecting the data. But actually running an experiment like that, really not a lot of work, involved, to be honest. In fact, although I say the RHS Plants for Bugs project would make a terrific long-term experiment, it isn't a long-term experiment. It ran for only 4 years, but even those 4 years were enough to generate some terrific papers. These 4, and those 4 were enough to completely transform our understanding of the relationship between wildlife and plant provenance, and essentially dispel the myth that you have to have native plants in a garden. We now know that's definitely in a wildlife garden. We now know that's definitely not true. So it's a shame that it ended. It's a shame that it ended, and it would have been nice. It would have made a lovely long-term experiment. Heaven knows what it would have told us if it had carried on for another 10, 20 years, because that's one of the beauty of long-term experiments. You set them up, you're never quite sure what they're going to tell you in the long run, and they often end up answering questions that hadn't even occurred to you before you started. Just a final point about gardens as long-term experiments, which is that we now know that gardens, private gardens, contrary to what people said and expected maybe 40 or 50 years ago, we now know that private gardens are absolutely terrific for wildlife. They contain a huge abundance and a huge diversity of wildlife of all kinds. And when you look at a typical private garden like this, that's not exactly surprising, is it? They're fantastically diverse in species, diverse in habitats, and you'd be surprised if there wasn't lots of wildlife in a place like that. But I just want to make the point that gardens are not all about the wildlife. They are at least as much about their owners, because gardens really are where the great majority of the population, the great majority of the time, have their only encounters with wildlife. So gardening as long-term experiments, not just about the wildlife, it's about the people in the gardens and the benefit and interest and enjoyment that people get from gardens as well. And just to underline that point, it's worth pointing out that in the typical British town or city, about half the green space is private garden, and the other half is public open space. And the trouble with the public open space is that too much of it still looks like this. Nothing wrong with this. I mean, it's terrific if you want to play football, but it's not really any much good for anything else. So private gardens really do bring a whole new dimension to urban green space. So I think what I'm saying here basically is there are, as far as I know, no urban horticultural, gardening, long-term experiments, but they wouldn't be very difficult to set up and run, I don't think. And I think they could tell us all kinds of interesting stuff. So maybe in the future, it'd be nice if there were. The second thing I want to talk about is the lessons for urban horticulture that we can gain from existing non-urban long-term experiments. And again, I want to divide this part of the talk into two halves. And the first is essentially about trees. And I want to talk about trees because the urban environment in particular is a bit challenging for trees. Cities are drier and warmer than the surrounding countryside, and that's a problem for many trees. And not only that, as the 21st century proceeds, and heaven knows maybe the 22nd century as well, that's only going to get worse, because the climate, especially in the summer, is going to get warmer and drier, and therefore life is going to get more and more difficult for urban trees. And so we really need to know, given that if you plant a tree today, a long-lived tree, you are hoping it's going to live for, I don't know, 200 years. We really want to know what we should be planting. Now, there's lots of interesting ways to get at that question. Well, let me say, first of all, that if you get it wrong, what you get is something like this. I love this picture. See these three nicely planted and cared for trees? Rather ironically, in the grounds of Sheffield University's experimental gardens. All three, as you could see, are in fact dead. And in fact, this is quite normal. At least 1 in 3 of all planted trees die quite soon after being planted. And the main reason they die is from drought. And that's just another sign that this is going to get worse as climate. So what trees should we be planting? Well, there's all kinds of interesting ideas. People are always on the lookout for useful things that you can measure that will tell you which trees will be more drought tolerant. Here's one example, a recent nice one. The water potential at which tree leaves lose their turgor, especially in summer. And that's certainly true. At the bottom of this graph, certainly the trees are a lot more drought tolerant than the trees at the top of this graph. But there's no real substitute in the end for seeing what happens to trees out in the real world, exposed to real drought conditions. And that brings me to one of the ECT's current portfolio of long-term experiments, Lady Park Wood, and in particular this paper. And this paper landed on my desk quite a long time ago now, when I was senior editor at Functional Ecology. And I knew the minute it arrived, actually, that this was a real winner, that this was going to be a great paper. And I think it's one of the best papers the journal's ever published. I thought that then, and I still think it now. There was a lot of media interest at the time in this. And what it's about what happened in Lady Park Wood before, during, and after the 1976 drought. And the 1976 drought, for those of you of a certain age who remember it, was at least a once-in-a-century drought, extremely severe drought. Probably a drought that's not really been equaled since, and not for quite a long time before either. And what the paper showed was that if you look at cumulative mortality of the two dominant trees in the wood, and this is the fate of the larger dominant canopy dominant trees in the wood from 1976 onwards, you look at cumulative mortality of beech and oak, you see there's a low level of mortality early on. This is the cumulative mortality from the middle of the 1950s, so it's not very much mortality. A little bit more mortality in oak than in beech, and all the oak mortality due to competition, because oak was slowly losing out competition with beech. And then from 1976 onwards, suddenly there's this huge surge in mortality in the beech trees. Nearly all of it down to drought. So this enormous surge in mortality here from almost nothing, huge amount of drought-induced mortality. And equally strikingly, the oak, which had this fairly low level of mortality, all of it from competition from the beech, for the next 15 years, suffered no mortality at all. And those mortality data are reflected entirely in the also in the growth data. The beech is divided here into two groups, whether it was severely damaged by the drought or minimally damaged, but in fact it's all the same. Nothing much happens for decades before the drought, and then suddenly there's this catastrophic decline in growth during the drought, and then a slow recovery. Same here. And interestingly, by the time this paper was published, the latest data they analysed was up to 2010, the beech had not recovered. And in fact, it may be that the beech never recovers from this 1976 drought. The oak, on the other hand, just carried along here quite nicely. And for 15 years after the drought, the oak, consistent with the no mortality, had this surge in growth, although later it went back to its original level. So I think this illustrates all the best things about a long-term experiment, really, that you need to have this long data series to see what's going on. Not only that, you need to have a long data series, not because things happen slowly in a place like an old wood like this, but because if you don't have a long-term data set, you miss the rare events which actually control exactly what is going on. So you could have watched this wood for decades before 1976. You could have watched it for decades from about 1990 onwards, and you would have seen different things. And you would have had no idea what was going on unless you had been actually watching in 1976. And what 1976 has done is completely shifted the whole wood onto a different trajectory, away from inevitable beech dominance towards probably not inevitable beech dominance, and much more of an oak wood. But from the point of view of urban horticulture, what it suggests is that beech is not the most wonderful tree to be thinking of growing in an urban environment now, and certainly not into the medium and long-term future. There's plenty of advice about what trees you should grow in urban habitats. This is a page from the TDAG database, the Trees and Design Action Group database, which is the Bible, really, of tree selectors for urban use. And I noticed that it says, it kind of hedges its bet slightly on beech. It says moderately sensitive to drought. But my suggestion is, from the Lady Park wood data, that moderately sensitive to drought is not good enough, really, that beech is actually more sensitive to drought than that. Beech is really quite sensitive to drought. And if you plant a beech tree in an urban environment in the near future, you're basically asking for trouble. And the second thing I wanted to talk about, on the theme of lessons for horticulture from long-term experiments, is about diversity, specifically about species richness of plant communities, and about species coexistence. And in a typical bit of a typical garden, that's kind of a fairly meaningless concept in a sense, because most gardens are like this planting diagram here. The plants that are in them are there because a gardener put them there, and they remain there because the gardener makes sure they stay there and looks after them and basically acts as a policeman to prevent the different species interacting too much. And so diversity is kind of pointless. Well, it's not pointless, but there's no ecological insights to be gained from looking at diversity in a typical flower bed. But there are two bits of gardens where ecological explanations for species diversity are required, I think. One of them, and this is the largest component of most gardens across the whole country, is lawns. And lawns are interesting because we think of them as being very controlled kind of environments, but in fact, from a floristic perspective, they are completely out of control. The gardener who owns a lawn really has no very close control over what grows in that lawn. Now, there is a fashion, a current fashion, or at least there is an attempt to create a current fashion for lawns that look a bit like this. In fact, there's a major campaign by Plant Life, the plant charity, which attempts to persuade gardeners to leave their lawns. Well, firstly, not to worry if they're a bit full of weeds, and secondly, to mow them a bit less to give those weeds a chance to flower. Now, fair enough, and I think a lawn like this looks absolutely beautiful personally, but I have to say there is a substantial fraction of gardeners out there, probably, I have to say, still a majority, who really hanker after a lawn that looks more like this. In other words, a lawn that contains only grasses, and ideally not very many of those either. So that's an interesting conundrum in a sense, how you get a lawn like this, because it's not very ecologically stable. Short turf has a natural tendency to be really rather diverse if it's left alone. At the opposite extreme, what many wildlife gardeners hanker after is a meadow a bit like this. Now, in fact, this is not a garden, of course. This is a real meadow, a real hay meadow in the Yorkshire Dales, as you can see from the barn. So it's not in a garden, but you get the idea. You get the idea. This is what many gardeners would like, and it's what many wildlife gardeners think they would like, even if they haven't thought about it very deeply. But what tends to happen when a gardener tries to create a meadow like this is that they get something like this. In other words, something that consists largely of a small number of robust species of grass. In this particular case, practically a monoculture of Holcus lanatus, and indeed not much of anything else. So there are two situations here, and paradoxically, one is striving for an unrealistically low level of diversity, and the other is striving for a rather unrealistically high level of diversity. And I think, as far as both are concerned, the granddaddy of long-term experiments, park grass, has interesting lessons for both kinds of endeavour. And in particular, out of all the hundreds and hundreds of wonderful papers written about parkgrass, this one, which is my personal favourite, much as I hate to say that, Jonathan Silvertown actually listening to this webinar, I think, but nevertheless, I'm going to say it. And what this paper shows is that there are, I think, well, this paper doesn't necessarily show, but there are various routes to a very low diversity turf, in other words, the ideal lawn for someone who wants a weed-free lawn. One of them is to mow like crazy, in other words, to behave like the owner of the groundsman of a bowling green or the putting green on a golf course. But another option is to manipulate soil pH. And certainly what we see here is, after 150 years of ammonium sulfate down here with no lime, we really do get down to a very low pH and a very low diversity. And what we've got down here basically is kind of the ideal situation if you hate weeds, which is we're just left with a couple of grasses here. Admittedly, neither of them are grasses that you probably would want in a lawn, but nevertheless, you know, you can't have everything, can you? And at the other extreme, it's really all about fertility. So if we arrange all the park grass treatments and along a sort of gradient of species richness, basically what you can see is the most species rich at this end are the plots that have never had any fertilizer of any sort, and the lowest diversity is right down at this end with the ones that have had complete fertilizer. And the problem with the typical garden soil, owing to the very successful marketing of fertilizers, which persuades gardeners to carry on shoveling fertilizer onto their garden without any regard for how fertile the soil already is most garden soils are definitely at this end. In fact, studies of actual levels of NPK in garden soils show that many of them are completely off the scale, even of agricultural, modern intensive agricultural levels of NPK. Probably the most fertile soils in the whole country are, in terms of just sheer NPK content, are found in gardens. And therefore, this is why creating a meadow is so difficult. Of course, how you get from there to there, how you do that is not easy, but that's a separate story. But park grass tells you what you need to do, even if it doesn't tell you how to do it. Okay, and that's it. Thank you very much.